Welcome back to our channel. In today's video, we will look into the continuation of our lectures on linear algebra. And in this video, we are looking into matrices and its operators. When we talk about matrices and its operators, in the last video, we discussed about the Cayley-Hamilton theorem, where we mentioned the keywords. In this video, the keywords here are matrices, operators. And in also one of our videos, we made mention of what matrix was all about and the types of matrices in two-dimensional space. We talked about the square matrix and the rectangular matrix. And the words here, matrix and the operators. These operators involve the tools acting on the matrix. Matrix on its own is an entity. Operators on its own is another entity. But there is an action that is acting upon the matrix to produce a result. That action by that matrix is done with the operators. An entity is on its own. Operators are on its own. Automatically, when there is an action, there is always a reacting force that comes together to produce a result. In the definition of our mathematics, we made mention of what mathematics was all about. And in this video, we will look into a brief concept that gives us the analysis of what we want to talk about here. When we have a generator set, for a generator to work perfectly and to produce a result, we require an input that generates the output. Likewise, in a matrix form, the matrix is on its own. The operators act on the matrix to produce a result. Let's look into a singular, a rectangular matrix. Let's say we have 2, 4, 7, 3, 2, 1. This is a rectangular matrix in two-dimensional space because it has the number of rows not to be equal to the number of columns. And it's also called rectangular because this length is always longer than the breadth. We have 3 entries, we have 2 entries, they are not the same. But when we have something of this form, 4, 1, 3, 2, 1, 4, 3, 2, 1, we can see that the number of entries here on the first row is the same thing, the second row, the third row. That is a 3 by 3 matrix. That makes it to be a square matrix. And we have said this is a rectangular matrix, rectangular, rectangular. This is a square matrix. Let's move to the operators. We said the operators are the tools that are applied on the matrix to produce a result. The rectangular, the square, or whatever form of matrix stands on its own until an operator is added upon the matrix in order to generate a result. Let's look about some operators here We have the same things, the same thing are called tools. You have plus, minus, division, multiplication, and whatsoever tool you wish to use, you can easily use that on the matrix itself to produce a result. And in our subsequent videos, we'll be looking into each operator acting on a matrix. This matrix will produce a result that is similar to a matrix after acting via the operators. Let's take a simple example. We have this rectangular matrix and we have another rectangular matrix. 1, 2, 4, 3, 2, 1. Another matrix, let's use this as the matrix 2, 2, 4, 7, 3, 2, 1. We can easily see here that we have two different matrices here, two rectangular matrices, and they are standing on their own. The only thing that gives an information to the matrices what to do has to be in a relationship with the operators. It is the operators. Each operator, whatever you want to use, acts on the matrices to produce a result. Let's assume we are using the positive operator here. We have positive. That means it is a command that tells the matrices what to do, which automatically brings up or produces a result. And in the next video, we'll start with the positive addition of matrices, division of matrices, multiplication of matrices, and also different application of the tools on matrices.